Hello, hello, and welcome to this video on JavaScript functions. So we have seen functions quite a bit, and this will be the penultimate video on functions. After this, there will be one more video, and we will wrap the function discussion. So we have seen that functions are first-class objects. Now, any first-class object will have constructor, right? So functions have a constructor as well. So that constructor is function with capital F. Now you can create functions like this. So this particular constructor can take any number of string arguments. The last function is the body of last argument is the body of the function, and before that we have the arguments. Okay, so x and y are the arguments to the function, and this is the body of the function. So this is equivalent to this particular function. Now we can call with two parameters, 2 and 5, it will return 10, this 2 and 5 will return 10. Now functions also have a length property, which is the number of arguments. Now for rest parameters, they don't count in length. And then we have name, which will be the name of the function. Okay. So, and we have a prototype object also associated with the function. Okay. This, I think we should comment this out, and we will uncomment this once we are done with this. Okay. So we have this much code right now. So we run this node func.this, and we have the result 1010 which is the name of the length of the parameters. Then we have anonymous, which is the name of the function, and this name is anonymous, right? And prototype is empty object. Okay. So if you want to see the prototype of S, then you see that. So it's the same. Okay. So that's what function constructor created objects like this. What you have to observe that the name was anonymous. Okay. The reason for this function constructor does not take a name argument. Like function literal, function constructor always creates anonymous functions. Now there are certain important stuff here. The function constructor allows JavaScript functions to be dynamically created and compiled at runtime. The function constructor passes the function body and creates a new function object each time it is called. If the call to the constructor appears within a loop, within a frequently called function, the process can be inefficient. By contrast, nested functions and function expressions that appear within loops are not compiled each time they are encountered. Also, the function it creates do not use lexical scoping. Instead, they are always compiled as if they are top-level function, as the following code demonstrates. Now, this is a bit weird function here. Okay. Ideally, what you want to do that you want to say let scope is equal to global, right? Which won't work in general with Node.js, and I'll explain why it does not work. Now, what happens is that since it does not follow lexical scoping, this local will not be bound to this function. Instead, this global should be bound to the function. But what happens in Node.js, top-level code is not really global scope. So this particular function, this particular code will be wrapped like this. Okay. So even this global is not really global. That's why we have to do this global disk.scope, and we have to make this global. One moment, I will comment this out. So we comment this out, and then you do it. So now you see it will print global because it does not follow the lexical scoping. Okay. And we run this and it prints global. This is required for Node.js. Okay. Now we will look at certain functional programming stuff. So we will cover functional programming a bit in this video, and next video will follow the functional programming to its completion. So we'll comment this out. Now, suppose we have an array 1, 1, 3, 5, 5, and we have total is equal to 0. We iterate over the length of the array, and we add the elements to total. So total would be 1 plus 1, 2, plus 3, 5, plus 5, 10, plus 5, 15, and length is 5. So this mean will be 3. Okay, then we compute deviation. So first deviation would be 2, 2, and then 2, 2. Okay, so total of deviation will be deviation into deviation. That is how much? 2, 2, 2, 2 will be 4, 4, 4, 4. So 4, 4 is 16. Okay, and then we divide the total 16 by length minus 1, that is 5. So that is 3, and then we take a square root. So roughly 2 will be the standard deviation here. Okay. Now this is the non-functional way of writing code. This is iterative way of writing code. So how we can make this functional programming? So we define two functions. One is sum, one is square. Okay. Two anonymous functions are there, and then we invoke reduce on data array, and we pass it sum array. We pass it the value sum. So sum is the function object which we have, not the value. And we divide this by length. So mean is 3. Then we map the deviations array, and we invoke on the data the map function. So we get x minus mean, and then we finally call the map on the square function and reduce on sum. Reduce on sum, and then we divide by the length, and we have the console log standard deviation, which is again 2. But this is not 100% functional yet. So to make it 100% functional, we create two functions, map and reduce, which where we split the arguments into two parts, a and rest parameter. And then on a, we invoke the args, okay, for both that. So now how we compute the mean? So mean is reduce data comma sum by data dot length, okay, and deviations are map data comma x minus mean, and then what our standard deviation is reduce on map deviations comma square comma sum and data dot length minus 1, and we finally compute the standard deviation. So that is the main difference between how you operate. So over here, there are no side effects. It's pure functional programming style. It might take a bit of understanding, or might take a bit of thought extra to really understand that what is going on here. And that is what is basically one of the reasons why functional programming is not very popular, because the code is quite compact. And then you have to think a lot that what exactly is going on. For example, take a look at this mean computation and standard deviation computation. Deviations is rather straightforward, but this standard deviation computation is not straightforward. You have to really spend quite a bit of thought that what exactly is going on here. And that is one of the reasons why functional programming code is so compact that it looks very elegant, but it's hard to understand. Compare this piece of code to this, okay? So many more lines, but it is very clear and you understand every line. It is broken into small pieces, and it works. The second problem of functional programming is that it relies on tail call optimization, and JavaScript does not have tail call optimization. Personally, if you ask me, it might look bad. Okay? This piece of code, this imperative piece of code might look bad, but it is clear and it is easier to understand. This code is elegant, but it is far more difficult to understand unless you understand reduce and map very well and how they work. Without that, you won't be able to understand this. Now, there are certain other things which we have already covered. Those are apply, bind, and call. We have already seen apply, bind, and call and how they work with the function. So I'm not going to repeat that here. And let's run this program. So it will print standard deviation 3 times, and 2 is printed for each. So with this, I will end this video here. And as a passing remark, I would suggest don't write code like this. Functional programming may be elegant, but don't do it. Somebody who will have to maintain the code will curse you. Okay. Personally, it is my personal opinion. Okay. You might reject it. It is not mandatory to follow my advice. But personally, I would prefer the imperative code simply because it is easier to understand. Okay. But that you can think I have that because I have not done a lot of functional programming. My interactions with functional programming languages are very limited. I have done a bit of scheme and list. Other than that, I have not programmed, only very basic stuff. So with this, I will end this video here, and we will meet again after 4th day, and we will finish this uh, discussion with more information on functional programming and how we can use them in JavaScript. So thanks a lot for watching the video. I wish you all the very best in your journey of learning JavaScript. So thanks a lot for watching the video. I'll see you in the next one. Have a great day and enjoy.